Okay, so my name is Keith Smith. I'm with Cartman Consulting, and just a little quick history on me. So I have a degree in mechanical engineering, and I'm a registered professional engineer. I've been in the energy efficiency business doing consulting work around the energy efficiency programs, looking at policy and such since I think about 2006. And a lot of that experience was out in Southern California, and coming out here to the East Coast, relocated with my family and getting into the different programs and things out here, specifically with New Jersey. And the energy code that we use for the baselines for the energy efficiency programs here is the ASHRAE 90.1. And so I'm going to be kind of taking us through a summary of what those code changes were, moving from 2013 to 2016. And then after that, Maria is going to take us through a little bit of Appendix G and also talk about a couple of ways that we would look to exceed code. As everyone knows, you know, the energy efficiency codes, these are kind of the basis of what the programs are based on. And so every 3 years, these get updated as technology, evolves and is adopted more widely in the industry. So every 3 years, there's the revision for that, and it, looks at things that as they become more cost effective, that they eventually become requirements. And the idea of the energy efficiency programs is to promote the adoption and installation of those higher efficient things. So let's look at what some of the changes were coming from 2013 to 2016. So with New Jersey, the 2016 is now the code that we're going to follow. And with the 2016 version of 90.1, they made over 120 changes. Now, not all of these are specifically impacting the energy use, and some of these are, such as administrative or clarifications to changes to alternative compliance paths. So with this, we have about 51 changes that are going to impact energy use. Most of them are decreasing energy use, and then there's a couple that increase energy use, which would ultimately decrease energy savings. But kind of that every 3 years they make that assessment and make the changes to those. So here's the different sections listed in 90.1 that we're going to look at, and the values in parentheses is where those impacts to energy are housed. So you can kind of see that primarily the most of the changes are happening in the HVAC area and also with lighting, because those are kind of the largest end uses in a lot of our projects. All right, so a quick ASHRAE 90.1 tip. So with the standard, there's different terms as you're going through that there are terms that are in italics, and the definitions are called out for these in section 3.2. And sometimes these definitions may have a small caveat that you might not be anticipating. So I would encourage you to look at those and be sure of the terms when you are applying for things, specifics within your project. Also, items that are in subsection 4, so this would be like 5.4, 6.4, they're shown in the red square, that these are all mandatory requirements, and for whatever compliance method that you're going through, that these are required. And so a lot of the changes did happen in this subsection, and the presentation is also going to touch on some of the prescriptive ones as well. So just kind of to be mindful of the difference between those two. All right, so kind of looking at a high level, kind of what does this change mean for, kind of at the building level between all those different components for envelope HVAC and such. A lot of the building types that we typically see in the P4P program are, offices, warehouses, and apartments. And so you can kind of see here what the impact or the additional savings amounts that the 2016 version of the code brings to those different buildings. So you can see that it varies between, say, 3 to up to 23% in the case of warehouses, and for all the other buildings in between. All right, so we'll start with building envelope. So this section is one of the mandatory ones, where previously ASHRAE 90.1, it had a list of acceptable materials and assemblies, and had provisions around kind of leakage rates with those. Now, the 2016 version adds in the option for testing. So now we have this different compliance option where they'll actually do a whole building pressurization testing to see if it meets that requirement. So you can do testing or the acceptable materials or the assemblies that are listed there in 90.1. Right. Also with the building envelope, they increased the insulation values for doors. Given that the doors are not a significant part of the building envelope, it is something that they did increase in this iteration. So for climate zones 4 and 5 here shows the both residential and non-residential U factors for doors, and the increase going from 2013 there in the column, I guess it's the column in the center, to 2016 in the column on the right. So similarly for fenestration, those requirements changed as well. So the solar heat gain coefficients changed only slightly, similar to the U values. And these are just kind of some of the examples for climate zones 4 and 5. For the HVAC section here, again, this one is going to be in the mandatory section, to where this addresses the automatic control of HVAC in hotel and motel guest rooms. So for those buildings that have greater than 50 guest rooms, they're looking to have controls for the HVAC. And what these controls will do will adjust the set points up or down after the guests vacate their room, or also for if a room is not occupied or not rented for some extended period of time, that those set points are set even further out of range until they are occupied by the guest room or by the guests. And so the automatic controls that they're referencing, that it does allow the use of key cards. So I'm not sure if how much traveling everyone has been doing lately, but the key card option where you come into the room and basically slide it in to tell it that you are there, and then when you take your room with you to leave to go out to dinner or the conference, that activates the control to change those set points. Oh, and forgot to mention this there in the beginning, that if you do have any questions along the way, feel free to type those into the chat, and my colleagues will provide answers there, or if you have anything there that can wait till the end, then happy to take on questions then. All right, so for chilled water plant monitoring. So what this one does is, with the chilled water systems, they ask that you measure the performance of the chiller, and you would take this data in 15-minute intervals and be able to summarize it in hourly, daily, monthly, and annual formats. And this would be maintained for a period of 36 months. So as John was saying in his presentation, that for the third incentive that is paid on, the kind of the realized performance and benchmarking, that having this data available would help to support showing that the efficiency values were maintained as designed, and it would also help the building owners to identify when things would potentially be out of line, and that those things can be addressed sooner than later to make sure that the efficient chiller is performing as intended. All right, so again, this one is targeting economizers, and so again, kind of going back to that persistence of savings and ensuring that both the energy efficiency measures and just equipment are functioning properly as intended. That different studies show that economizers can save 9 to 32% of cooling energy use depending on the location, but they often don't function properly in about 70% of installations. So how are some ways that we could make sure that these are continuing to operate? Is that the 90.1 now requires fault detection and diagnostics for economizers. So kind of assessing a couple different values of are the temperature sensors working during the conditions when the economizer should be functioning? Is it actually doing that? Are the dampers modulating appropriately? Is there excess outdoor air being provided when it should not be economizing? So, and again, these are all kind of things that would help to support that incentive number 3, the performance-based one. All right, so again, with economizers, so this one is in section 6.5, so it's a prescriptive one. So this is kind of a caveat where it's, if there is a chilled water cooling system that does not have a fan or has induced airflow and under specific capacities, that the economizer would not be required. So this is just something to keep in mind for, when your projects are, not the, I guess, the typical or standard design, that ASHRAE 90.1 does have different provisions for those system types as well. All right, so section 6.5, return and relief fan control. So basically the keys here are that the relief air rates need to maintain building pressure through differential supply return airflow tracking and control of the relief system based on outdoor air damper position. And fans shall have a variable speed control or other devices that are similar. And the exceptions to this would be the return or relief fans with a total motor size less than or equal to 1.5 horsepower, or if there are staged relief fans with a minimum of 4 stages. All right, so with ventilation design, with this one here, we do see a good number of projects that have ventilation that exceed requirements, and there's always been a penalty for this now. So this would also impact the prescriptive requirements. So also need to include that in the modeling, and it would show up as a penalty. So looking at these different standards, that it's good to pay close attention to what the ventilation requirements are, and that we're modeling and sizing equipment appropriately around that. All right, for exhaust air energy recovery, so this is kind of a terminology change between the two codes, where in 2013 there was energy recovery effectiveness, and 2016 has enthalpy recovery ratio. And so they kind of changed the metric just slightly. And this, again, kind of pointing back to the terms that are italicized, that it's always good to make sure that we're looking at those and applying the right metrics when we are looking at compliance or building the energy modeling. Also, they changed this to where the exceptions for systems exhausting toxic fumes was removed. All right, so moving on to heat rejection equipment, looking at the fan speed control. So this is the full language from both 2016 and also 2013. And basically, if the condenser tower fluid cooler has 5 or more horsepower of fan motor, whether it's a single fan or multiple, that the fan speed needs to vary. And in 2013, it only applied to motors that were 7.5 horsepower or larger. And the exceptions to this are condenser fans serving multiple refrigerant or fluid cooling circuits, and also condenser fans serving flooded condensers. So it's a slight update there, in that the motor size, or actually it's more kind of the total connected motor horsepower that is being evaluated rather than just the single motor. All right, so within section 6, the HVAC, there are many tables of minimum equipment efficiency. So there's 16 different tables, and 9 of them did not have any changes at all. So many of you, I assume, are familiar with the types of equipment that are listed in these tables. Covers everything, from air conditioners, heat pumps, furnaces, boilers, heat transfer equipment, refrigeration, other things. So the ones listed here, these did not change. And then we'll go step quickly through the ones that did change. All right, so this is in regards to the minimum efficiency for axial fan closed circuit cooling towers. So the specific efficiency metric for those is GPM per horsepower, and it increased up to 16.1 from 14. So it's kind of specific to that type. All of the rest of the table is remains the same. And Table 9 for electrically operated variable refrigerant flow air conditioners. So this is a popular system, and we do see lots of these. And there are many of these that exceed these kind of published minimum efficiency values. So as you can see here, the 2013 values are listed there, I guess in the center column, and then the 2016 values are there on the right. So you'll notice that the EER is the same, but the IEER is increased slightly. So looking at that's the integrated energy efficiency ratio. And if you're not familiar with that, or even if you are familiar with it, that it is, kind of it's a rating that targets more kind of what the actual operating efficiency of the unit is going to be. So it basically weights operation at different percentages in time of where it would be at reduced capacity and also reduced ambient. So that reduced ambient condition is kind of the part that is the larger driver for improving the efficiency, because when it's a little cooler outside, the compressor doesn't have to work quite as hard, and so the system becomes more efficient. So the EER is kind of the worst case design condition, where the IEER tries to account for how that efficiency improves during those reduced ambient and part load conditions. So I included the ASHRAE 1230 equations down there for you if you're interested to kind of see how the percentage of those, I guess, those operating bins fit. So those are the changes for VRF air conditioners. Similarly, they did the same for the VRF heat pumps. So I didn't include the ASHRAE values. It's kind of the same methodology, but you can see here that the EERs stayed the same. The IEER increased slightly, again, to account for that kind of a normalized or anticipated operating range. And with some of these slides, some of the tables were pretty long, so I'm just kind of providing these as informational so that it is comprehensive, and you can reference back to these slides if needed, or go directly to the tables within the ASHRAE standard. All right, so table 11, this looks at air conditioners and condensing units that serve computer rooms. So within 2016, from 2013, they expanded it quite a bit to really align better with the ASHRAE 1360, which is the standard for rating these types of equipment. Also, some of the metrics around the efficiency ratings, where it's a net sensible coefficient of performance versus the sensible coefficient of performance. So I listed out what those definitions are here, and I'll show you an example of kind of what that looks like in the tables. So if you notice that in addition to expanding the table, the format of it has also changed, where it's kind of more that gray and dark gray versus the old typed amount. And that was actually a change too, that going from, it was presented in columns, and now it's presented single full page, so it's a little easier to read, a little less crowded. Going on to this, where the 2013 version of it had kind of the cooling capacity for, these are for air-cooled units. And you can see it has, okay, there's downflow and there's upflow units, and we have these three sizes. So in 2016, it's the same air-cooled equipment types. They still have the same three size categories, but now they've differentiated between the upflow units to have ducted or non-ducted, and there's also a horizontal flow unit. Also, now we have these different class ratings of where these units are rated. And so you can kind of see that the different types have different ratings that they follow. So just so that it's consistent, and that we're sure that we're using the right rating for the right type of equipment that we're specifying. Same table here, this is for water-cooled units. So similar expansion between all the types of units. This is water-cooled with fluid economizer, glycol-cooled, and glycol-cooled with fluid economizer. So you can see also too the efficiency ratings also improved for the most part. Let's see. Yeah, so you can just kind of look through as examples to see how those changed in addition to that expansion. So kind of have to read a little bit between the lines to make sure that the comparisons are correct. All right, so our last table here, sorry, second to last table. This covers vapor compression-based indoor pool dehumidifiers. Yes, there is a standard for that. And sometimes we don't realize all the types of systems that 90.1 would apply to, but this is part of them. So if you have a school with a pool, or maybe a large hotel with an indoor swimming pool, that the system is now part of ASHRAE 90.1. So it's if anything, it's an opportunity to identify another area to save some energy. All right. So with the DX, dedicated outdoor air systems without energy recovery. So these are these weren't previously in 90.1 2013. So now we have a table for without energy recovery, and there is similarly a table for with energy recovery. So we have two new tables for minimum efficiencies. So again, 15 is without, 16 is with energy recovery. All right. With HVAC, this is our last slide for air conditioning, and then we're going to be heading into service water heating. So with this is going to be a mandatory requirement because table 6.8.2 is referenced from within section 6.4.4.1.1. So for example, just looking at a climate zone 4, if we had an exterior duct with heating only, this would be our attics above insulated ceilings, parking garages and crawl spaces. The requirement was R3.25, now it's R6. So P4P has, like from John's presentation, has both new construction and existing building offerings. And this is a common measure that would apply to both. So if there was an existing building and there were improvements being made to the installation, that the baseline would actually be what the energy code is, and we'd have to exceed that. In water heating, this was just the single change. So the efficiency requirements for service water heating have changed, which is partially due to the DOE requirements. And so you can kind of see how those equations change there for the different types of water heaters. Section 8, so this is related to transformers. So within table G, that's in appendix G, that the direct type distribution transformers must be modeled if the proposed design transformers exceed the efficiency requirements of table 8.4.4. If modeled, that is the baseline. And so you can see the efficiency changes only slightly, but since given the load that is going through these transformers, that even that small incremental change could result in potentially in a larger number. And a quick note on that the compliance with that is not required by the New Jersey State Energy Code, and it will not be required for P4P except for that section, which is required by EP Act 2005. And receptacle control is required by section 8.4.2, may be treated as a measure if included in the scope of work. So then there are no changes in the New Jersey Energy Code with respect to 90.1 section 8. All right, so with lighting alterations. So there was quite a few changes in lighting, as I noted there in the introductory slides, that it was largely HVAC and lighting. So this will be a good part of the presentation, and there were quite a few changes. And so going through a couple of the exceptions first before what we get into those changes are. So with this, it's an exception for alterations, and this is an instance where the stringency around enforcing code was somewhat relaxed. So previously the trigger was 10%, and now it's 20% of the building. So the rules around not increasing the installed lighting power and still meeting the LPD requirements still apply, So there's no need to also include additional controls in the scope for kind of these smaller alterations. All right, so with the interior lighting controls, so there are four new exceptions, and these are pretty specific and not necessarily applicable to every single project. So going through these, it's more just kind of for awareness, something to keep in mind as you're developing your projects. So the exception for item C, this applies to restricted to partial automatic on controls, where it's limited to 50% unless it's an open office plan and is less than 600 square feet. Item F applies to automatic daylight responsive controls for top lighting with photocell control. And it's exempt for spaces that have adjacent structures that shade the area for a significant period of time, or for spaces with low overall skylight effective aperture. And again, that skylight effective aperture, that's one of the things where it's a pretty solid equation, lots of variables that is described within that definitions section. So you can check to see if that exception may apply to your project. Here, item G, this applies to automatic partial off and full off complies controls. The general lighting power in the space shall be automatically reduced by at least 50% within 20 minutes of the occupants leaving that space. And if you'll notice in that first line where it says this requirement does not have to be complied within spaces that meet all four of the following requirements, that if you look in the 2016 language, it actually says 3, but it lists the 4 exceptions. So I kind of caught this when I was looking through. I was like, oh, this might be a typo. And sure enough, looked in the 2019 version of the code, they have revised it to say 4. So I have revised it here to say 4 as well, because you have to comply with all 4 of those things for the exception to apply. All right, so moving on to item I, this relates to a scheduled shutoff, and it exempts spaces that would operate for 24/7 operation, patient care, or areas where there would be a safety or security risk if the lights are turned off. And then also there's that whole building metric of that the lighting load doesn't exceed, that prescriptive amount. Exterior lighting control. So 9.414, again, it's one of the mandatory ones, that this is about turning lights off automatically when sufficient daylight is available. So they updated that lighting not in section B, which is the building facade and landscape, and lighting for signage be reduced by 50%, which is increased from 30% back in 2020. So they've upped the amount that it has to be reduced. Also, this is a mandatory control, and if it meets one of the following conditions, that from 12 midnight within 1 hour or during any period of no activity has been detected. Continuing on with exterior lighting control. So this addition extends controls to outdoor parking areas to reduce by 50% when no activity has been detected, no more than 15 minutes. And it also sets limits on how many fixtures can be tied to a single point of control. Here, with looking at the individual lighting power allowances for the exterior, there's pretty much a reduction across the board here in all the different areas. So the next couple slides will kind of look through what some of those details are. So it's, pretty much on the order of, 10 to 50%, depending on which area that you're looking at. So the values shown there in parentheses are the ones from 2013, and the values next to them are the ones from 2016. So just looking at kind of the base site allowance that we can see, these are some of the reductions that are, close to 30%. So it will impact the potential amount of savings that we would have been able to claim for these before the new code took effect. So again, this is just a continuation of that table. All right, so quick note on dwelling units. So this was a new requirement that says not less than 75% permanently installed fixtures shall use lamps with an efficacy of 55 lumens per watt or have a total luminaire efficacy of at least 45 lumens per watt. So just be mindful of which lumens per watt value that you are citing for your project. And the exception for this would be anything with dimmer controls or automatic control devices. Looking at the whole lighting for the building, kind of this is the kind of usually one of the bigger ticket items. So it comes in two flavors. There's the building area and space by space method. And real quick refresher on these for those that may not be completely familiar with it. So building area method is the allowed lighting. It's derived on a representative mix of spaces to get a total number. So this allows flexibility between the spaces so long as the total is less than the allowance. So it's basically what is the lighted area, what are the total wattage of all the fixtures in that area, does it meet the requirement? Good. And so it's kind of the representative building of office or hospital, things like that. And then these are the many of the building types that you could potentially use. Also note that the LPD requirements for many of these was reduced with the new version of the code. All right, and here's kind of a list of some more of those different building types that we might see. And last slide here. All right, so the second flavor of creating our lighting power allowance is the space by space method. So this is basically looking at the space types within the building, figuring out what the allowance of lighting is allowed for that space type, and creating kind of a more customized aggregate to get basically a building LPD that is more representative of our building. So kind of similarly within that, there's trade-offs between the spaces to where it is provided, but that when we're calculating that kind of customized building total allowance, as long as we still come in under that number, that some spaces could be overlit or underlit. Again, here listing the LPD values from 2013 compared with 2016. So the ones that are highlighted red are the ones that decreased. So just looking at this page, the Performing Arts Theater, that one reduced by maybe 15% or so. And I'll cycle through these. I did list all of the spaces here as just kind of an overview to see which, how many of these space by space method allowances changed. Next slide. So you can see across the impact. So there is one there that is green. So you'll notice that's one of the ones that went up for mechanical rooms, but we know how large those spaces are and how impactful they are to the project. So not hugely significant. So looking through the lighting here, so this provision is for additional interior lighting power. So we have spaces within retail that have kind of the specialty lighting for showcasing different things for sale. So furniture, clothing, sporting goods, cars, things like that. So there's allowances for additional things there, and basically they reduced by about 25%. And there's an equation that you can go about figuring what type of retail area that it is, and kind of figuring out what that allowance is. So in the 2016 version, it reduces slightly, so by about 25% for retail and decorative. Section 10, this is our last slide. This one is for electric motors. So what they did for 2016 is they expanded the table above 200 horsepower to go all the way up to 500 horsepower, and lists efficiency values for those. Also included the addition of 8-pole motors. So these are the nominal full load efficiency values that we use in our baselines. So if it is applicable to your project, that the table has expanded to include those. All right, which brings us to the end of the presentation. So I guess I'll turn it over for or open it up for questions before handing it off to Maria to take us through changes in Appendix G.
Great, thanks, Keith. Yeah, we had just one question came in, and it's a general question about the availability of the slides. Obviously, Keith went through a lot of information, some of which may have been new to some of you, and maybe some of it wasn't, but regardless, it's a lot of information. So we will be making the recording available, and we can also distribute the slides if that would be helpful to the group. So the recording will be posted somewhere on one of our websites. We'll confirm where and let you know. And the slides themselves we can distribute via email or put them up for download on the partner portal. So we'll follow up with those details and make sure you're able to get your get the information you need.
Okay. Yeah. Fantastic. Yeah, because I put in all of the table reference values and section numbers and things to where hopefully it's easy to follow, and yeah, reference the code.
If anyone has any other questions, you can type them in the chat and in the questions box. I mean, you can raise your hand on your dashboard there, and I can unmute you. No? Okay. Well, we'll have another opportunity for Q&A at the end of the presentation. So if you have questions, just hang on to them, and we'll circle back. Okay, so Maria, I think you're ready to go, so I'll hand it off to you.
Yeah. Hello, everyone, and I hope you can see my screen. Yes?
Yes.
Okay, perfect. So my name is Maria Karpman. My background is in energy efficiency, in mechanical engineering and computer science, and I've been involved with energy efficiency for the last 20 plus years. I'm a member of 90.1 committee, subcommittee involved with developing requirements of 90.1 section 11 and appendix G, and I also do work with local codes such as development of New York Stretch, and I'm really excited to have been involved with New Jersey Pay for Performance program for the last 6-7 years. So my presentation today will cover two topics. The first one is brief. I'll talk about changes to 90.1 Appendix G requirements since the last version of the program. And then I'll go over some ideas on opportunities for exceeding code and maximizing building performance and maximizing your incentive under P4P new construction program. So I'm going to start with just a high-level overview of Appendix G and its general concept, and you may already be familiar with that. So you develop two models. The first model is the model of the proposed design, and that reflects design documents and specifications. So the second model is a virtual building, and we call it baseline design. And this virtual building serves as a point of reference for evaluating performance of proposed design. So one interesting thing about the baseline design since the last version of code is that this baseline design is no longer reflective of minimally code compliant building. So now baseline design is configured to meet requirements of 90.1 2004. So in order to meet the new code, the proposed design must exceed baseline by set margin. And then in order to exceed code, this margin should be further increased. And we're going to talk about this math on the next slide. But both models, the proposed design model, baseline model, must be developed following the rules of 90.1 Appendix G, using the same simulation tool weather file and utility rates. There are a number of simulation tools that meet requirements of Appendix G. In P4P, most models that we see, I would say overwhelming majority of models that we see are developed using either eQuest or train trace. But there are other tools that could be used. We do ask that if you use any of these other tools other than eQuest or train trace, you reach out to the program beforehand so that we have an agreement on simulation reports that would need to be submitted, and so that we could reaffirm that the tool that you are considering in fact complies with 90.1 and is allowed in the program. So few words about how the simulation results for these two models, baseline design and proposed design, are used to determine P4P incentives. So P4P incentives are based on percent improvement beyond code. And you see the calculation here on the slide. So all these calculations are hardwired, incorporated into P4P reporting templates. So, but it's important to understand for you, what goes on behind the screens in order to correctly report the information. So what's important here is that you need to separate the energy use of the baseline model into regulated and unregulated components. And this is what you see here in the denominator on the slide, or at the numerator on the slide. So baseline building regulated energy cost is, again, energy cost of system and component regulated by 90.1. And it's multiplied by building performance factor, or BPF. So building performance factor reflects increase in stringency of 90.1 between 2004 edition, which is again the basis of the model baseline, and the current version that for this version of the program would be 90.1 2016. So that's the math that happens here. So again, building performance factor is the way to adjust stringency of the requirements of 90.1, and the building performance factor required to meet each edition of 90.1 is included in section 4 of the standard. And with each new edition of 90.1, the new set of values are provided. There is a value for each climate zone and building type. And with each new edition of 90.1, this the values of BPF go down to reflect extreme increased stringency of the requirements. So we have a separate training coming up on that discusses the reporting the templates used for pay-for-performance programs. So at this training, we will discuss, one of the topics discussed would be splitting energy use of the baseline into regulated and unregulated loads. So basically, regulated energy use is energy use by systems and components that have requirements prescribed in 90.1 sections 5 through 10. And that, for example, includes heating and cooling systems, fan energy, pump energy, energy consumed by lighting systems regulated by code in section 9 of 90.1. Examples of unregulated energy use include energy use of plug-in equipment, such as kitchen appliances, consumer and office electronics, industrial processes that are not regulated in 90.1, for example, custom refrigeration systems, lighting that is exempt from the standards such as emergency lighting, and transformers that are not regulated in Section 8 of the standard. So, and this slide shows at a glance change in values of BPF between 90.1 2013 and 2016. So again, there is, and this reflects, this change in BPF reflects increased stringency of requirements of P4P program as well as 90.1. Excuse me. So the green bar here shows energy cost of regulated loads coming out of the baseline. So that's based on 90.1 2004. So the blue bar is energy cost of regulated loads compliant with 90.1 2013. So you can see that it varies for different building types. And for schools, the difference is the greatest. For multifamily, the change is the least. And then the difference between blue bar and yellow bar is increase in stringency of P4P target between 2013 and 2016 version of code, which is basically the previous edition of the program versus the new one. So depending on building type, it would be 6 to 9% reduction in energy cost of regulated loads. So fairly noticeable increase in stringency of the requirements. Previous version of the program adopted 90.1 2013 with addendum ban package, because this addendum package basically took simulation requirements of Appendix G 90.1 2013 almost all the way to 90.1 2016. There are not as big of differences in simulation requirements between the previous version of the program and the new version of the program. So on this slide, I highlighted the few examples of where rules have changed, and perhaps the most significant and impactful change is in respect to baseline service water heater, and this is the service water heater that you would model in the baseline model. So for all buildings except for multifamily, the program follows Appendix G rules, where baseline must include one central service water heating system for each building area type in the proposed design. That means that if you have a mixed-use building, say part of the building is office, and then there are a couple floors of retail space on the lower floors, you would have two central service water heating systems modeled on the baseline, one serving office floors, another serving retail. If you don't have mixed-use building, then there would be one service water heating system modeled in the baseline serving the entire building. So you will never have dedicated or point of use water heaters in the baseline. So that's for commercial and industrial buildings. For multifamily, the program P4P rules deviate from Appendix G and allows using the same system configuration in the baseline as what is specified in the proposed design. So if proposed design includes in-unit water heaters with water heater in each apartment, for example, then that's what would be modeled in the baseline as well. So aside from that, there are some updates to baseline chilled water system controls. There are also a number of updates and clarifications related to modeling requirements for refrigeration systems. And we recently released tech tip on refrigeration systems, and that was covered on partner call, and the slides are available on partner portal, so I'm not gonna go through this changes again now. So one other important change that I want to mention is that previously the incentive tier was based on improvement of the proposed design over code expressed in energy cost. So with the new program, another option is added, and this option is to determine incentive tier based on source energy instead of energy cost. So this calculation will be automatically done in the new P4P ERP template, but this option makes this option is more favorable to projects that use electricity for space heating or surface water heating. And this table at the bottom of the slide illustrates the reasoning behind that. So in New Jersey, electricity is very expensive relative to gas. So I checked Energy Information Administration website for the last year. One therm of gas average cost was 91 cents. Kilowatt hour of electricity average cost was 13 cents. And if we converted into dollar per BTU cost to normalize for units, we see that electricity is almost 4 times more expensive than natural gas BTU per BTU. So when we look at site to source energy conversions in column C, they are more favorable to electricity, and these conversions are based on the current EPA Energy Star portfolio manager conversions. So if say we're comparing energy consumed with condensing gas boiler versus electric heat pump, you can see here, depending on performance target metric, site energy, source energy, or energy cost, either gas boiler or electric heat pump may come as a winner, may be perceived as more efficient system. So with energy cost metric, that again was the only option allowed under the old program rules, the projects that use heat pumps, even efficient heat pumps, always or rather often were perceived as less efficient, would qualify for low incentive compared to projects that use gas heating, and this issue is addressed by program switching to, or rather allowing source energy alternative. All right, so I think I'm going to pause for a minute to see if there are any questions about this first segment, and then I'll move on to the second segment, which is opportunities for exceeding 90.1 2016.
Yeah, so there's one question that came in on our questions box. Let's see if I can get it up here. Is the compliance calculation equation used to adjust for the fact that EQRESS does not use the latest version of ASHRAE 90.1? Essentially what I understood is we create the energy model and then adjust the results using BPF to get the percent improvement beyond code. Should I read that again? So I think it's a two-part question.
If you can.
So I guess the first part is I don't, I'm not sure if eQuest not using the latest version of ASHRAE 9.1, that I'm not sure if that's actually true. Right.
Yep, so I can address that. The models, when we say that certain software tool meets requirements of 90.1, it just means that this tool meets or has required capabilities. And these capabilities, this requirement related to capabilities have not changed between, they haven't changed for a while actually, but they didn't change between 2013 and 2016. And this includes requirements such as that it's the tool run simulation at least hourly time step. It can model 10 or more HVAC zones. It can model hourly variations in schedule and operating conditions, and so forth. So these requirements relate to like general capabilities of the simulation tool. They are not specific to the version of 90.1. So eQuest is compliant with 90.1 2013, 2016, 2019 because it meets these requirements that I summarized to you. And there is a subsection in 90.1 Appendix G that is titled Minimum Simulation Tool Capabilities that lists all these requirements. So, and what was the second part?
And then, yeah, so then the second part, essentially what I understood is we create the energy model and then adjust the results using the BPF to get the % improvement beyond code. And so I think that it probably speaks a little bit to what we'll be talking about on the next training, which is how that functionality is embedded in the ERP tables.
Correct, but basically we try to do it really easy for you, where what you do is you create two models: baseline model, proposed design model. For the baseline model, you need to specify for each end use whether it's regulated or unregulated, and there's some help around that included in P4P guidelines and also in the compliance form. But aside from that, all the calculations are completed, are like hardwired in the compliance form. So you need to understand on high level what these calculations are. You need to understand that the baseline that you are modeling, it's not current code. So if P4P performance target is for tier 1 is at least 5% better than code, it doesn't mean that you just need to improve by 5% relative to baseline, because baseline is 90.1 2004. So, but again, you just need to focus on following the modeling rules described in P4P guidelines and Appendix G, and then the compliance forms and the reporting templates that you fill out for P4P take care of this additional calculations.
Yep, and we'll actually take a closer look at how that all works on our second training, which I'll mention at the end of this one. So we won't spend too much more time on it here, but hopefully that answered the question. If it didn't, like I said, please, send a follow-up in the chat box or raise your hand on your dashboard and you can elaborate. I'll unmute you. Otherwise, no, okay. I think we're good.
Okay.
All right, go ahead.
Again, the next topic, exceeding 90.1 2016. So resources, that we use to develop these sections include ASHRAE Advanced Energy Design Guides. So there is now Achieving Zero Energy series, and so far there are 2 guides in this series, and that's one for K-12 schools, another for offices. Another resource is design guide for multifamily developed by NBI, New Building Institute. Another useful resource is ASHRAE Standard 189, Standard for Design of High Performance Buildings. Another resource that is close to home is New York Stretch Energy Code 2020. And New York Stretch is adopted as the basis of New York City Energy Code. So it exceeds requirements of 90.1 2016, but again, based on the analysis completed in support of New York Stretch development, the requirements of New York Stretch are cost effective. And because there is really no difference, not big difference between New Jersey and New York City area, this is a great reference for cost-effective opportunities to exceed 90.1 2016. So all these references that you see here, I recommend that you check them out, and they're all freely available. So ASHRAE Standard 189, you can purchase it, but you can also view it online. So if you are not downloading it, it can be viewed from the ASHRAE website free of cost. For New York State Energy Code, there is a code itself that is available online, and there are also various studies in support of New York Stretch, such as cost effectiveness studies that you can check out if you are curious of incremental costs involved. And then another resource that I want to mention, and this one is not free and a little bit more theoretical than the other ones, is ASHRAE Research Project 1651. Development of maximum technically achievable energy targets for commercial buildings. So this project, the goal of this project was to look at technologies that are either already available on the marketplace or should be widely available in the near future, and see what kind of improvement or what kind of energy use intensities can be achieved with these technologies on various commercial building types. And you can see the findings of this research project on the slide, and that gives you some idea of target energy use intensities that you can hope to achieve on your highest performing projects. So on the next slides, I'll go through some technologies, some performance characteristics recommended in these references that I mentioned to you. And I'll go through different building systems, starting from envelope, then lighting, HVAC, and so forth. So for the envelope, the Net Zero Advanced Energy Design Guide for K-12 schools recommends energy use intensities for heating and cooling that you see on the screen. So there are different recommendations depending on the climate zone. New Jersey's climate zones 4A and 5A. So when you analyze envelope, and this should be the first step in optimizing building performance, check out how the heating and cooling load intensities of your project compare to these targets. So for opaque surfaces, and that includes walls, roofs, slabs, exposed floors, standard 189 recommends 5% reduction in U factors relative to 90.1. And then you can see recommendations for U values from Net Zero Advanced Energy Design Guide for non-residential and New York Stretch. And when I looked at these tables, what was interesting to me is that, as you can see, there's really no difference in what's recommended by Net Zero Advanced Energy Design Guide and what's recommended by New York Stretch. And that's true for roof, and that's also true for steel framed walls. And that highlights again that as we improve insulation, increase insulation of opaque envelope, we at some point start to get to the point of diminishing returns, where further increasing insulation does not generate savings or does not generate a lot of savings. If you're focused on improving envelope, this U values that you see for New York Stretch are perhaps target values to start with, and then if project budget allows, you can further improve those, but don't expect significant savings being generated from increasing insulation beyond these levels. And in fact, for some buildings with high internal heat gains, you may see penalty when you increase envelope insulation. Because in these types of buildings, having higher insulation sometimes prevent building from rejecting some of the heat from internal gains to outside. For fenestration, again, standard 189 recommends 5% reduction in U value and solar heat gain coefficient compared to 90.1, and then you see on the slide recommended maximum U factor and solar heat gain coefficient for New Jersey climate zones. And at the bottom, you see recommendations from New York Stretch 2020 and NBI multifamily guide. Again, there is exact match between what's recommended in Net Zero Advanced Energy Design Guide for non-residential and the requirements of New York Stretch 2020. So when it comes to improving envelope, perhaps one of the biggest opportunity is related to fenestration area and orientation. So Net Zero Advanced Energy Design Guide recommends 30% window to wall ratio as a starting point, and window to wall ratio is the ratio of vertical fenestration area to gross above wall area. So this is the starting point, and then again you can see like walk from there to see how increasing this fenestration area affects building performance. So for commercial buildings, when you increase fenestration area, you may get higher savings from daylighting, but oftentimes this 30% window to wall ratio depending on location of the window within the space, can really produce maximum achievable benefit from daylighting. So where increasing fenestration area beyond this limit may not help daylighting, but it will certainly affect heating and cooling loads of the building. So with residential building types, including multifamily, hotels, motels, higher window area from energy efficiency perspective is a pure penalty, because in residential spaces there is no daylighting, so we're not really reaping any benefit from increasing window area there. So NBI multifamily guide does not prescribe window area or recommend window area, but it does set target overall U value for opaque wall and fenestration, and this is U.071. So, and again, if you want to achieve this U value with higher window area, you would obviously have to have higher performing windows and higher performing opaque surfaces. So another important detail is that you want to reduce window area on the east and west elevations, so that most of the windows are either on the north or south. And this is because on east and west elevations, sun will be shining directly into the space, and you can't really prevent that by adding shading, because obviously because sun rises in the east and sets on the west, and in fact there are some stories that projects that were buildings that were built with significant fenestration area, and that is a commercial project that was built with very high fenestration area, that had also high solar heat gain coefficient, had significant comfort issues, and that happened in Massachusetts, and there was even a lawsuit there because occupants were unable to use the building because of significant glare and significant internal heat gains through windows. And then another important factor to think about related to fenestration area is to minimize use of opaque spandrel panels, because these panels are typically much more conductive compared to your regular insulated wall, so they really penalize building and worsen building performance. So moving on to air leakage. So Keith mentioned that air leakage testing is now an optional compliance path with 90.1 air tightness requirements. Interesting, New York Stretch 2020 actually requires air leakage testing for buildings 25 to 50,000 square feet in floor area that are less than 75 feet high. And this building should demonstrate air tightness of 0.4 CFM per square foot at 75 Pascal. And this is an opportunity for you to claim performance credit with P4P, because if building performs testing, air leakage testing, you can model leakage rate based on the testing in the proposed design, and that will, any savings associated with air leakage reduction directly contributes to your incentive tier. Standard 189 and Net Zero and Advanced Energy Design Guide target is 25 CFM per square, or rather 0.25 CFM per square foot at 75 Pascal. And these values are generally achievable, and low values are achievable. And in fact, now there is proposal to change 90.1 requirements from current 0.4 CFM per square foot at 75 Pascal to 0.3 CFM per square foot, because this lower air leakage values have proven to be achievable and cost effective. So, but if this change passes, it would be effective as of next edition of 90.1, which is 90.1 2022. Another important aspect of envelope performance is thermal bridging. New York Stretch has mandatory minimum R3 thermal breaks at penetrations, including parapet walls and balcony projections. So again, if these are insulated, that will directly contribute to performance target for the project. NBI multifamily guide has minimum R5 continuous insulation at all penetrations. Pay attention to thermal bridging, especially this is important for envelope dominated building types such as multifamily and schools. All right, so moving on to interior lighting, and there we think about specifying efficient lighting fixtures, and then also making sure that space is not overlit, where we don't have too many lighting fixtures specified for the space. So you see on the slide that Net Zero ASHRAE Advanced Energy Design Guide suggests 125 lumens per watt fixture efficacy and dimming capability. NBI multifamily guide suggests luminous efficiency that ranges from 60 lumens per watt to 100 lumens per watt, depending on fixture wattage. And I included on the slide some sample lighting power density requirements for common space types such as offices, classrooms, corridors, and so forth. So generally, you can significantly improve over 90.1 2016 by specifying all the LED fixtures that largely became standard practice, and making sure that you do not over specify lighting. You don't specify too many fixtures in the space. So on to exterior lighting, and I included the targets from New York Stretch and also Net Zero Advanced Energy Design Guide. So again, notice here a direct match between New York Stretch and Net Zero Advanced Energy Design Guide, which highlights that these levels of lighting are achievable. So that's what you should strive for. It also highlights that if we get submittal where you show lighting power density that is significantly better than what's recommended in Net Zero ASHRAE Advanced Design Guide, we may question your calculations, because it's not uncommon in the submittals to claim, for example, larger area of the parking lot that is actually lit, and that produces artificially low lighting power densities in the submittal. So again, if your submittal shows lighting powers significantly lower than what you see on this slide, like be prepared to justify the numbers that you're reporting. So lighting control requirements are very stringent already in 90.1 2016. So daylighting is expected in and must be specified in most spaces with windows, except residential spaces such as apartments, hotel, motel, guest rooms. There should be lighting controls specified in corridors, and there were some questions concerning the spaces before, because some projects thought that it's unsafe to have occupancy sensors there. But again, now that's part of the code requirements, and it's also a requirement of New York stretch. So next, I'll talk about opportunities related to HVAC, and there, on a high level, opportunities involve using more efficient HVAC system type, such as, for example, radiant heating and cooling, VRF, heat pumps, ground source heat pumps, using designs that include dedicated outdoor air systems, or alternatively or additionally, opportunities involve specifying systems with higher efficiency, for example, high performance boilers, high performance chillers. So here are a few examples of high performance systems based on ASHRAE Advanced Energy Design Guide. You can have high performance multi-zone VAV system, and this system type is used in many cases in the modeled Appendix G baseline. Even though it's the same system type in the baseline, you can you can improve over baseline performance by having higher cooling efficiency, supply fan with minimum turn down of at least 30% of design flow, adding exhaust air energy recovery, using condensing boiler for heating, and using circulation pumps with variable speed drives, and consuming less than 12 watt per GPM at design conditions. So for reference, Appendix G baseline allowance is 19 watt per GPM. Big opportunity with the systems, big opportunity for improvement is reducing energy consumed by fans, and that may be achieved by reducing external pressure, external static pressure drop in the ductwork, specifying larger size ductwork, also reducing flow rates by reducing design supply air temperature, and also specifying supply air temperature reset controls. Another option that we actually see pretty often on projects going through P4P is VRF heat pumps with dedicated outdoor air system. So there again, opportunity for savings involves specifying units with high heating and cooling efficiency, using backup heating through condensing boiler in the perimeter zones, reducing pump energy to no greater than 12 watt per GPM in design conditions, and using dedicated outdoor air system in conjunction with VRF heat pumps that provide heating and cooling to spaces. Another option for HVAC system type is ground source heat pumps with dedicated outdoor air system. We don't see many projects with that system type, so hopefully there will be more in the future. So there are two main design options for this system type. There might be multiple single package water source or ground source heat pumps located in individual zones sharing the groundwater loop, or there can be multi-split VRF heat pumps sharing the outdoor unit, and the outdoor unit is connected to the ground loop. So a very important consideration for ground source heat pumps is minimizing pump power. So because with ground source heat pumps, obviously the ground heat exchanges, so depending on its design, the pumping energy can be significant. There is a study quoted in Net Zero Advanced Energy Design Guide suggesting that pump power can vary from 0.04 to 0.21 horsepower per ton of cooling capacity. So clearly very wide variations, and recommendation in ASHRAE Net Zero Advanced Energy Design Guide is to shoot for no more than 20 watt per GPM pump power at design conditions. And then another option for HVAC system design is fan coils with dedicated outdoor air system, and this we do see on projects. So again, important considerations are pump power and fan power. So there are targets that you can see on the slide for chilled water pumps and hot water pumps, also targets for fan powers for terminal units. So ECM motors should be specified with pump power, or rather fan power, less than 0.38 watt per CFM. These fan coil units, since they do not provide dehumidification, they're located within zones, can have higher chilled water supply temperature, which improves chiller efficiency. So many of the systems that I described rely on dedicated outdoor air system, and this slide summarizes types of dedicated outdoor air system that may be used in conjunction with different HVAC system types used for heating and cooling. So basically, all of dedicated outdoor air systems, all types of systems should use exhaust air energy recovery, and this is no brainer because that would be required by code. And then cooling source can be DX, or it can be a chiller in systems that use in systems involving fan coils. And then heating source can be either gas-fired furnace or heat pump, again depending on design of the main HVAC system. And here are target efficiency levels of dedicated outdoor air systems based on ASHRAE Design Energy, Advanced Energy Design Guide. And a few words about multifamily projects. We do see a lot of multifamily projects going through P4P. So heating and cooling system types that we see include VRF. We also still see P-tax on some projects, which is not, of course, considered high performance, but VRF is high performance ground source heat pumps. Radiant heating and cooling is another option. With ventilation strategies on multifamily, ventilation ideally should be balanced. either energy recovery ventilator serving individual apartments, or there may be central systems with air being exhausted from kitchens and bathrooms of the apartment units, preheating, outdoor air being supplied to apartments. It's important to remember that ventilating apartments by pressurizing corridors is prohibited. So it conflicts with ASHRAE standard 62.1. So you can't pressurize corridor, you can't supply outdoor air to corridors, anticipating that it will also provide outdoor air to apartments through undercuts under the entrance door. So again, this is not an allowed option. Moving on to service water heating for projects for building types that use a lot of hot water, such as multifamily, hospitals, hotels. The baseline service water heating type is gas. So you can improve over the baseline by specifying high performance gas water heater. Another option is to specify high performance electric water heater, and that in order to be competitive relative to the baseline with electric water heater, you really need to look into heat pump water heater, and you see some recommended efficiency levels for heat pump water heaters shown on this slide. Other opportunities related to service water heating include minimizing distribution losses and energy consumed by recirculation pumps. These are not opportunities for credit when you do energy modeling, because with Appendix G, we are not accounting for distribution losses, and we assume the same recirculation pump energy in the baseline and proposed design. But as was mentioned by John and reiterated by Keith, we do have final incentive number 3, that is based on actual realized performance, and distribution losses and other parasitic loads associated with service water heating can account can double service water heating energy consumption. So make sure that you pay attention to this aspects in the building design. Another opportunity is to install wastewater heat recovery on such as on shower drains, so that the water going down the drain, the hot water going down the drain, preheats incoming water, and obviously that would only work if you have in-unit water heaters. There are also refrigerant heat recovery option that you can use to preheat service water heating. And this last 2 bullets shown on the slide will show savings, both once the building is constructed, but also you can get credit for that when you do energy model. And then last but not least, remember for other opportunities for performance credit, you can specify high efficiency office equipment, Energy Star servers, Energy Star computers, high efficiency building transformers, low energy elevators, Energy Star residential appliances, and so forth. All right, so that's all I have.